So now let's move on to multiple regression. So in simple regression, we just had one x, and now we're going to think about adding more x's. And let's first kind of motivate why we want to do that, or kind of remember the issues we ran into in simple regression to kind of motivate us to why we want to add more x's. So we have seen a couple of issues with a single independent variable. So what I meant by that is in our simple regression framework. So the first kind of issue is based on this really big assumption we've been talking about. We've been making this assumption, we used it when we proved that the beta hat was unbiased. But this assumption often fails. And I think we've talked about that. Often fails. Ooh, my writing's really bad right now. This assumption often fails. And we've hopefully we're going to do another example just now so you can see it. Same example we kind of did before. But this assumption often fails, which kind of means that the assumption we're kind of using to get this property we want in our estimators is often failing, which is kind of not ideal, right? And the second issue we might have with this simple regression with just one x variable is that we may want more flexibility in our functional forms, or in our functional form. For instance, I know we could get a little bit of nonlinearities in our, we kind of introduced some nonlinears to the natural log, but we might want to be able to have things like decreasing returns or increasing returns. And adding more variables is going to allow us to allow us to do that. All right, so that first issue that we just talked about is this idea of expectation of u given x1 often fails, right? So let's remind ourselves of an example of that. So let's have two regressions. Regression A, we have wage as our dependent variable, beta 0 plus beta 1. Let's say again, years of education plus u. So here's our simple regression. Then let's imagine we have another regression that has more variables. So we're going to use an alpha, just a parameter, just instead of the beta, I'm writing alpha, just like gamma, just like whatever. But now let's say we have another variable, experience. And we'll put epsilon, same thing as u, just the error term. So notice that, maybe I'll get out the blue again. In this first regression, experience is kind of stuck in that error term. This part of it, I should say just this part, is in there. Right? So it's in that error term. In A, experience would be in U. Which, probably, I'll say may, cause the expectation of U given X equals 0 to fail. That assumption to fail. I mean, that's probably because experience and education are probably correlated, right? People with lots of education might have more experience, or the opposite. If they're in school a long time, like I was forever, maybe they don't have as much experience. Either way, there might be some correlation between the two. So education, well, let's make sure it's not add, and experience are probably correlated. And experience probably influences wages. And so if we ran this regression, this assumption is probably going to fail, which means our estimators in this regression for beta hat 0 and particularly beta hat 1, remember we relied on this assumption when we showed that it was unbiased. So we're not going to get an unbiased estimator of the effect of education on wages if we don't account for these variables that are correlated with education and influence wages. So this is one of the reasons we might want to start adding more x's to our model. Now let's think about kind of how that might, adding more x's might also allow us to have kind of different functional form relationships between variables. So the second issue that we kind of just talked about is this idea of we may want a more flexible functional form of this relationship, functional form of this relationship between x and y, or the effect of x and y. So again, let's think of, we just kind of talked about two of them, two regressions, and let's think of a third one. So wage equals gamma 0 plus gamma 1 education plus gamma 2 experience. So it starts to look like that regression B, but let's add another term here and have that experience squared. And so by having this quadratic for experience, by having both experience and experience squared, we're going to allow kind of diminishing returns depending on the values of that we estimate for gamma 2 and gamma 3. This would allow us to have diminishing returns to experience or increasing returns to experience. It kind of matters what these values would be. So we'll kind of keep it general here, but in C, we can get nonlinear effects of experience on wages. So it just allows us kind of more flexibility in this functional form. So having this squared term can allow, some relationship that might look like this, where we have wages and experience. Or it could look, depending on the values, right, could look like this too. But it allows us these nonlinear relationships, besides just using logs, which might have certain properties we don't want. Yeah.